Late spring in the Pacific Northwest usually means deep greens and damp earth, but step to the edge of the tree line and the hillsides blaze with a solid wall of bright butter yellow flowers. This is Scotch broom. In Washington state alone, its present strains an estimated $143 million annually in lost timber productivity and grazing land. It aggressively forms dense thickets, chokes out native wildflowers, and stalls reforestation efforts across millions of acres. The display is undeniably gorgeous, a sweet-smelling golden sea humming with bumblebees. Yet land managers treat it as a noxious weed that must be eradicated on site. Labeling a plant a pure biological villain is an easy narrative, but this weed-centric framing ignores the precise biological mechanics that summoned the shrub to these hills in the first place. Look at a healthy, intact Douglas fir forest. Mecanopy is tight. The understory is a thick web of ferns, mosses, and deep shade. Scotch broom seeds germinate poorly in these conditions. The shrub requires intense, direct sunlight to survive, meaning it simply cannot penetrate or conquer a mature forest. But strip the timber away and scrape the topsoil down to mineral dirt, and the environment radically shifts. The established biological networks are severed. The soil is exposed to direct heat and rapid moisture loss. Intense wildfires create the exact same void. When the heat scorches the earth, the delicate fungal networks die, leaving a sterile, sun-blasted landscape where native species struggle to take root. Scotch broom does not cause these open wounds. It is an opportunistic pioneer that rushes in to stabilize a landscape that has suffered catastrophic trauma. Down in the dirt of a fresh clear-cut, the soil is effectively dead. Nitrogen and organic matter have washed away or burned off. When a seed sprouts, its root tip secretes flavonoids, acting as a beacon. Rhizothium bacteria detect this dialogue, swim to the root, and fuse to form housing nodules. Here, they pull inert atmospheric nitrogen, converting it to feed the plant and surrounding ground. Through this cross-kingdom partnership, Scotch broom manufactures its own fertility, injecting nitrogen and organic matter into a biological dead zone. That underground generosity fuels an entirely different strategy up above. To heal the site, the plant must first monopolize it. Broom surges upward, growing multiple feet a year. Its deep taproot quickly drains the upper soil layers of summer moisture, while its dense canopy of wiry green stems plunges the ground below into immediate shade. Young native saplings, like Douglas fir or pine, planted in these thickets are starved of sunlight and hydration. Without resources, their biomass can drop by nearly 96%, frequently resulting in mass die-offs. To protect its dominance, the shrub pumps its shoots full of quinolisidine alkaloids. These bitter, highly toxic chemical defenses deter deer, elk, and livestock, ensuring the stand remains entirely unbothered by grazers. By midsummer, its black seed pods dry out, cracking under the heat with an audible pop. This explosive tension launches thousands of seeds outward. For over a century, human activity terraformed the Pacific Northwest. Industrial logging produced thousands of continuous, sun-drenched clear-cuts, an endless expanse of perfect habitat. Ecosystem triage is a hostile takeover. To effectively stabilize severe trauma, the responding plant must exclude all competition and command total control of the environment. But this total control has a strict expiration date. Individual Scotch broom plants are short-lived, senescing and dying off after about 10 to 15 years. During that decade, the shrub relentlessly sheds nitrogen-rich leaves and stems. This decaying matter slowly rebuilds the topsoil, raising the carbon and nitrogen levels back to a functional baseline. The improved soil allows those few surviving, taller native trees to finally gain a foothold. As they push upward and close the canopy, they cast a deep shadow that deprives the sun-loving broom of the light it needs, effectively killing off the original colonizers. Yet the plant ensures its legacy before it dies. The soil beneath the aging stand is loaded with millions of hard-coated seeds, lying dormant for decades. They are waiting for the next fire, the next clear-cut, the next disturbance. Because these seeds can survive for up to 80 years, attempting to violently rip the plant out of the ground only churns the dirt and triggers the next generation to sprout. Modern land stewards are adopting a new approach. Instead of waging an endless, expensive war of eradication, they treat dense stands of broom as an invitation to participate in the repair process. In its native European range, rural communities long relied on the plant's tough, wiry stems, binding them into thatching for roofs, fences, and the sturdy sweepers that gave the shrub its name. Today, ecological restorers cut the green, nitrogen-dense biomass before it goes to seed. By chipping and hot composting the material, they convert a highly competitive weed into a free, potent fertilizer that accelerates the growth of native flora. The thicker, woody stems are charred in a low-oxygen kiln to create biochar. This locks the plant's captured carbon into a stable, porous structure that improves water retention when worked back into the recovering earth. Scotch broom thrives exclusively where the earth has been fractured. By reading its golden blooms as a diagnostic signal rather than an invasion, we stop fighting the ecosystem's first responder and learn how to finish the job of healing the land.